Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Ahmad Nauman, and today this is our third lecture on hydrochloric acid industry. So let's first briefly overview the outline of our lecture and also the just overview what we have learned in our previous lectures. So we have already two lectures, and today is our third lecture. In first lecture we had introduction about hydrochloric acid, that what is hydrochloric acid and what are its main uses, and we also discussed about some physical properties of HCl, and then we discussed briefly the history of HCl, that when it was discovered historically and when it was used first as per the reports available. And then we also discussed about the natural sources of HCl in the world, and then we discussed about some general characteristics of hydrochloric acid, and we also discussed about the toxicity of hydrochloric acid to human beings especially. And then in our second lecture of this series, we discussed about the HCl production at global level, and we discussed about the major areas where HCl is being used, and what are the countries where HCl is actually mainly used. And then we discussed in quite in detail about the some very important chemical reactions of hydrochloric acid, and especially we discussed about its reaction with carbonates and bicarbonates, with sulfides, with metals, and also we discussed about its reaction with metal oxides and metal hydroxides. So in our today's lecture, which is third in the series of hydrochloric acid industry, so we will discuss about the methods which are used for the production of HCl at industrial scales. So there are so many methods which have been used nowadays, and there are many new methods which are being developed in different research labs. However, we will in our today's lecture we will overview about the HCl production method, especially from the historical method, which is the production from sulfuric acid and common salt. And then we will discuss other methods, for example the burner process for HCl production, Chlor-alkali process, Chlorination process for the production of HCl, and we will discuss some process where HCl is produced as a byproduct in the organic synthesis, and also in the organic waste incineration. So these are the main and key points which we will discuss in our today's lecture. So let's start. So the most common and ancient method that have been used from centuries is the production of hydrochloric acid by using common salt, that is sodium chloride, and the sulfuric acid. And this method have still been in practice at industrial level in different areas of the world. This method is the most simplest methods for the production of HCl, and in this method, as you can see in the equation, that we treat sodium chloride with sulfuric acid, and that results in the production of Na2SO4 sodium and HCl. So this is the overall process which have been used from centuries for the production of hydrochloric acid. So there can be different orientation of the reactor in which we can carry out the synthesis of HCl by using sodium chloride and the sulfuric acid. And because it can be produced at different scale at different industries, and even at the small scale. So the reactor configuration may differ from case to case, and however, broadly speaking, mostly the reaction is carried out in either in open roaster, or we call it in a muffle, or which we call it closed roaster. So there are mainly two configuration, either open or closed type, and both the case, we actually the furnace is actually called as salt cake furnaces, and both are in use nowadays. However, the main mechanism is that we add sodium chloride and sulfuric acid in a reactor, and heat is provided to the mixture, and that results in the formation of sodium sulfate that is collected, and HCl is actually removed from that reactor. However, that HCl may have some impurity of the some we can say that residual sulfuric acid that is normally collected in the first step in the when we cool the hydrochloric acid. And then the cooling tower, mostly the residual sulfuric acid is being separated, and then we get the pure HCl, which is further after this next step, after passing through some cooling and passing through some absorber. And that is normally the overall general procedure which is being used in the different kinds of plants for the production of HCl.
Laboratory, hydrogen chloride gas can be prepared by reaction of concentrated sulfuric acid on sodium chloride. For the preparation of HCl gas from a salt, we need reactants, sodium chloride and concentrated sulfuric acid. We need apparatus like flat bottom flask, thistle funnel, burner and beakers. Now, let us see procedure. Set up the apparatus shown in the animation. Place a common salt, like sodium chloride, in flat bottom flask, and pour concentrated sulfuric acid through the thistle funnel. A rapid evolution of gas occurs, and when the mixture in the flask is gently heated, and HCl gas is evolved. This HCl gas is again passed through sulfuric solution for drying. Now, this dry HCl gas is collected by upward displacement of air in the jar. Since it is 127 times as heavy as air, and is very soluble in water. C. Reactions take place in the experiment. NaCl plus H2SO4 is heated on 200 degrees Celsius. It gives NaHSO4 plus HCl gas. This reaction goes continuously by evaluation of HCl gas, and it can occur up to the stage of formation of sodium sulfate by heating NaHSO4 plus NaCl at 200 degrees Celsius. Note that this is a reversible reaction.
Another way to produce hydrochloric acid is through the burner process. As the name suggests, it involves the burning of chlorine and hydrogen to give the hydrochloric acid. In this process, we use a burner nozzle. उसके अंदर जो है ये दोनों gases pass की जाती हैं. They are ignited inside that combustion chamber. और after we get the HCl gas को pass किया जाता है again through the cooling tower to get the liquid hydrochloric acid, and because in which we are getting the pure HCl, so it's very easy to control the concentration of hydrochloric acid while the synthesis process. This burner process can also be carried out in the presence of UV light instead of the burning nozzle. So in that modification, we combine chlorine gas with hydrogen in the presence of UV light, and that reaction results in the production of hydrogen chloride gas. This process is also exothermic, so we call that instrument as the HCl oven or HCl burner. And the resultant HCl gas, as we discussed earlier, is absorbed in deionized water, and which gives us the chemically pure hydrochloric acid. The burner process has the advantage that it gives a very pure product. The hydrochloric acid produced through burner process is very pure, and thus it can be used in the food industry where the highly pure HCl is required. Again, here there can be different configuration of the reactor, and there have been so many configurations which have been employed worldwide. So we will see some common examples of the HCl chambers which are used for common chambers which produce HCl by the burner process. For example, this is a simple explanatory diagram in which we can see that we add hydrogen and chlorine gas, and it is there is a flame where it is burned together, and they actually produce the HCl gas, which is collected in the chamber, and we get the dry HCl gas. So this is the very simple description of the production process, and the same can be modified, as you can see here, when there is an addition of membranes, and also the addition of some cooler chambers and absorber chambers, and instead of dry HCl product, we can even get the hydrochloric acid directly in this kind of the chamber. So here we add both hydrogen chloride, which is burned in the similar way as before, and then through membrane wall it is passed to that HCl is collected in the absorber chamber, and then it can be added with water to get hydrochloric acid, or even we can collect the HCl gas. We have different configurations for the production of HCl by burner process, but if we just want to have a just look of a flow sheet diagram that how this process is carried out, so we can see over here. So you can see from the your top from your left corner that there is the combustion chamber, and in the below the combustion chamber you can see there are two inlets. One is for chlorine and the second is for hydrogen, and these the combustion take place inside the combustion chamber, where hydrogen and chlorine under high temperature actually mixed and form hydrogen chloride gas. This hydrogen chloride gas is taken to the absorber chamber, or what we call as a cooling chamber, where it is cooled down. This gas is cooled down, and as you can see from the right corner, there is another inlet where we add dilute acid and water under control. So those also enter in the cooling chamber, and in the bottom of the absorber chamber, this HCl gas and that mixture of water and dilute acid, they actually combine, and that results in the formation of HCl hydrochloric acid, which is collected and stored under the absorption chamber in the HCl storage tank. So this is the overall the flow sheet diagram of the burner process for the production of hydrochloric acid. Common method for the production of HCl at the industrial level is as a byproduct of chlor-alkali industry. We know that in a chlor-alkali industry we use sodium chloride and water to produce chlorine, sodium hydroxide and hydrogen. through the process of electrolysis. So आफ्टर जो मिक्सचर होता है सोडियम क्लोराइड और वाटर का, जिसको ब्राइन कहा जाता है, उसको इलेक्ट्रोलाइज किया जाता है, तो हमारे पास जो है वो क्लोरीन गैस, सोडियम हाइड्रोक्साइड एंड हाइड्रोजन गैस आते हैं. जो प्योर क्लोरीन गैस होती है, इट कैन एक्चुअली रिएक्ट विद हाइड्रोजन गैस इन द प्रेजेंस ऑफ यूवी लाइट टू प्रोड्यूस HCl गैस. उस HCl गैस को कलेक्ट किया जाता है एंड देन इट इज़ लिक्विफाइड एट लो टेम्परेचर इन द कूलिंग टावर, एंड जो हमारे पास जो हाइड्रोक्लोरिक एसिड जो है वो इन द कंसनट्रेटेड फॉर्म जो है वो कलेक्ट हो जाता है. एंड वास्ट मेजॉरिटी ऑफ जो HCl के जो यूनिट्स हैं पूरी दुनिया में एट इंडस्ट्रियल लेवल, दे आर मोस्टली connected with the chlor-alkali industry. It is a very common method of synthesis of HCl nowadays. The flow sheet diagram for the HCl production process via byproduct of the chlor-alkali process. So as we can see that we are using water and सोडियम क्लोराइड सोल्यूशन और व्हाट वी कॉल ब्राइन सोल्यूशन, और उसका जब आप इलेक्ट्रोलिसिस करते हैं, यू कैन सी इन द मिडल ऑफ द फ्लो शीट डायग्राम द प्रोसेस ऑफ इलेक्ट्रोलिसिस ऑफ द brine solution. So it results in the production of three things. First, we can get caustic soda or sodium hydroxide, which is around 30 to 32% in this process. इसको concentrate किया जाता है to get around 50% sodium hydroxide. And then in the bottom of electrolysis, we can see that there are two more components which are produced in this process, which is chlorine and hydrogen. So one is that hydrogen is simply passed on to the cooling tower for its compression into H2 gas, and another way is to just liquefy the chlorine to get liquefied chlorine gas. And that actually chlorine is also used for the synthesis of NaClO for its different applications, or we can use it for the synthesis of HCl with when by combining with hydrogen gas. So this is the flow sheet diagram of this process for HCl synthesis. Little bit more detail and in another descriptive diagram. So on the left side is the typical process of a chlor-alkali plant, and on the right side is the production of hydrochloric acid from the byproducts, that is chlorine and hydrogen from the chlor-alkali plant. So in the as you can see in the chlor-alkali process, that we are having brine solution, and we are carrying the process of electrolysis. So we the input is the standard brine solution, which is the saturated brine, and that is actually producing the caustic soda during the electrolysis process, and that brine is recirculated in this process, the depleted brine. And in the top you can see that we have two byproducts. One is chlorine gas and the second is the hydrogen gas. So these two are both are collected separately. So the chlorine is taken to the cooling tower, and then in the end we get the wet chlorine. Similarly, we have the hydrogen, which is passed through the cooling tower, and we get the wet hydrogen at the end. And then we can take both of these products to the separate combustion plant, which is using the burner process for the formation of HCl. So we can see on the right that we take the chlorine and hydrogen, and then we have another nitrogen gas, which is used for the burning process. And when they combine together, the number 3 is here is the point number 3, as you can see, is the burner process, where chlorine and hydrogen are burned together, and they form hydrogen chloride gas. and there you can see there is one on the bottom there is an inlet of cooling water, and the top there is a cooling water out. So it is because this process is exothermic, so continuously it is cooled down. And then there is water is added to the synthesis unit, which results in the formation of hydrochloric acid after reaction with hydrogen chloride gas. And that hydrochloric acid is collected at the bottom, and but still there are some of the non-absorbed gas, so which is still present in the chamber. So that is actually recirculated again and can be again used in the burner process and formation of the hydrochloric acid. So this is the overall process for the manufacturing of hydrochloric acid through the chlor-alkali plant. Second method is it is a byproduct of chlorination process. वैसे तो काफ़ी सारे processes हैं जिनके through HCl को industrial level पे synthesize किया जा रहा है, but one of the most common method for the synthesis of hydrochloric acid is by the byproduct of chlorination. So when we chlorinate some hydrocarbons, as we can see in the equation, when we produce these chlorinated substances, it gives HCl as a byproduct. After the chlorination process, when we get some chlorination gases, so we also get some HCl in the form of vapors, and that actually gas stream which contains hydrogen chloride is taken to the absorption column, जहाँ पे जो है concentrated HCl है उसको separate कर लिया जाता है, और जो chlorinated compounds हैं उनको separate कर दिया जाता है. and the जो residue जो इसमें भी बचता है as was in the previous case, जो है उसके अंदर से जो है वो further जो है उसको next process में उसके अंदर जो है remaining part होता है HCl का, which is most definitely because it's the leftover, so we get some dilute HCl in that process. Another method to produce HCl at the industrial scale is through the incineration of the chlorinated waste at a high temperature. और हम देख सकते हैं यहाँ पे in the equation where chlorinated hydrocarbons are burned in air or in the presence of methane and air to produce carbon dioxide, water and HCl. Hydrochloric acid is also produced during the synthesis of different organic products, and also during the fluorination of chlorinated organic compounds. We can see in the first equation where the chlorination of organic compounds results in the formation of HCl as byproduct. Similarly, during the fluorination of the chlorinated organic compounds, we get HCl as the byproduct, which can be separated and used. These were some of the most commonly used methods for the production of hydrochloric acid at industrial level. And another method which is also occasionally used for the hydrochloric acid production as a byproduct is through thermal decomposition of heavy metal chlorides. So let's see an example here. When we treat FeCl3 and heat it at very high temperature, it results in the formation of iron oxide plus water, and it also produces HCl as a byproduct. So this is another example of the process where HCl is produced as a byproduct. So these were the different commercially and industrially used processes for the production of HCl. Some of them we have discussed in detail, and some we have discussed in briefly. So there are many other methods which have been used for the production of HCl, but they are beyond the scope of this lecture, so it's not possible to cover all the those methods which have been in practice for the production of HCl. So that's all for today's lecture. Thank you so much for your patience, and if you have any question or confusion, please let me know. Thank you. Allah Hafiz.